All right, here we are starting chapter 10, evolution and natural selection. Evolution is a genetic change in a population over time. So as that definition implies, evolution works on populations, not individuals. You either have the right genes for an environment and you survive and reproduce, or you don't have the right genes for an environment and you die before you reproduce. That's essentially what natural selection is. And that idea was jointly proposed by this guy, Charles Darwin, and this guy, Alfred Wallace, in 1858. Now, most of the work that we know about how natural selection works, and most of the research was done by this guy, Charles Darwin, and that's why he's given much more credit for it. So let's briefly talk about Darwin's theories of evolution, and then we'll get to his main theory, his mechanism for how evolution occurs, and that's natural selection. So his first theory is called perpetual change, and that is that the earth and all life are constantly changing. So what Darwin says is if the earth is constantly changing, then organisms on that earth have to constantly change to that constantly changing environment. Next is gradualism. Gradualism is that the wide variety of organisms in existence are a result of the accumulation of gradual changes over time. So he didn't look at evolution and making large leaps, large changes over time. He looked at it making small changes over small periods of time, which will result in large changes over long periods of time. Next is multiplication of species. And this states that evolutionary processes produce new species by the splitting and alteration of older species. So here you have some speciation events that then cause more and more types of organisms to evolve over time. And if you follow that back, you get to his common descent, that all life descends from a common ancestor. Okay, so that's just working back all those splittings back to the original there, and we talked about that in class. His last theory that we're going to talk about and spend a lot more time on is natural selection. In natural selection, this is a differential survival and reproduction of organisms whose genetic traits better adapt them to a particular environment. So there's a couple key things in that definition. So differential survival and reproduction. So right at the beginning, we're saying that not everybody survives the same. And because not everybody survives the same, not everybody's going to reproduce the same. And those that reproduce more have better genes for that particular environment. And that's the other key, is this gets us to what's better for a particular or a local environment. So let's look at the preconditions for natural selection. And one is that members of a population have heritable variations. This is essential for natural selection. So everybody is different, and we can pass those differences on. So that's essential, because if we're all the same and environments change and it's not good for one of us, well, it's not going to be good for all of us. And there is no mode in which we can evolve out of that. All right? So just to let you know, new variations can be helpful or they can be harmful. So this is showing all these different people, all these different dogs, showing these variations that occur in populations. So how do we get variations? We get variations through mutations. That's a change in genetic material, or by recombining those genes in sexual reproduction. So, but we also know that we're going to produce something that is going to be very similar to us. This is Goldie Hawn and her daughter, and they look very, very similar to each other. All right? So, the first precondition here is that members have heritable variations. We're not all the same, and we can pass those differences on to our offspring. All right? Next, there are many more individuals produced each generation the environment can support. All right? So what we see here is that this is just showing, a pig with a lot of offsprings. This little pig can't get in there, so it's not going to get any resources, right? So, the runt might not make it. But let's think about this a different way. So Darwin looked at this as an example of looking at elephants in Africa. And he thought, just over a couple hundred years, if all the elephants in Africa survived to adulthood and reproduced, then very quickly the entire continent of Africa would be overwhelmed with elephants. And so we have a struggle to survive because resources are limited in the environment. So we're not all going to find food, we're not all going to find shelter, we're not all going to find water, all right? And of course, a lot of us are going to die before we reach adulthood. That's the way it is in the natural world, all right? So, first precondition, we're all different. We're going to pass those differences on. The second is, well, not all of us are going to survive to adulthood. The third precondition here, so getting a little ahead of myself, is that some individuals have adaptive characteristics that enable them to survive and reproduce better than others. So, here's the other thing. We're not all created the same. Some individuals have better characteristics for an environment. And if they have better characteristics for that environment, then they are going to survive and reproduce more. All right? So, those individuals those individuals that have better genes for that environment are going to capture a disproportionate amount of resources, and they're going to convert this into a disproportionate amount of offspring. So this is something that's kind of alien to us. We think about how many children we want to have. Organisms don't do that. They have as many offspring as they can possibly have. So, so spiders don't think about, oh, I have enough spiderlings out there, I don't need to make more. If a female spider captures more flies, she's going to convert that into more spiderlings. That's the way the natural world works, okay? So this leads us to the idea of what is known as fitness. And fitness is the reproductive success of an individual relative to other members of a population. Meaning, if you have more offspring than other individuals in your group, you are winning the fitness game, all right? We have a tendency to think of fitness means the biggest, fastest, and strongest, and that's not always the case here. Now, it might be that to be better for that particular environment, you have to be the biggest, fastest, or strongest, but not necessarily. If you're a tree frog and you blend in better to the bark on the tree that you're in, well, you're going to be less likely preyed upon by birds or owls or anything else, all right? So that would be a trait that increases their fitness. All right, so once again, with these preconditions, so we all have, we're all different from each other and we can pass those differences on. Not everybody survives to adulthood, but even those that do survive to adulthood, some are better for that environment, have better traits for that environment than others. So that leads us to the consequences. So what we're going to see here is that an increasing proportion of individuals in succeeding generations are going to have those adaptive characteristics. And this is just trying to show this here. So here we have some beetles on a dark background. And so those lighter beetles are more easily seen by predators. And so they are then removed from the population, and those genes are also removed from the population. And so what we're going to see over time is we're getting darker and darker beetles in that environment. And so the result of natural selection is a population adapted to its local environment. So an adaptation is an inherited characteristic that enhances an organism's ability to survive and reproduce in a particular environment. An adaptation is the result of natural selection. These guys are now adapted to this darker environment. All right? So what we can see with natural selection here is natural selection is actually a limiting process. So through sexual reproduction, through mutations, we're going to put out variation into the environment. The environment's going to limit that variation, and so what's left over are those who can survive better for that particular environment. But if I change this environment, that might not be good for these dark beetles.